Back to callback solutions. Today we're going to be looking at airflow. Now, while a good technician is going to look at the return and supply and calculate how much CFM they have, a great technician is going to look at static pressure. The reason you want to look at static pressure is that you're going to know that you have the proper amount of airflow, which means you'll have to be able to check the good charge, and that means you're going to be pulling the correct amount of humidity, making the system as efficient as possible. Now, to do that, we're going to need a couple tools. All right, some of the tools that we're going to need to complete this is our drill with a uni bit. We're going to need a manometer, and you can have your LCD screen one, or you can have your digital ones that hook up to your phone. And you're going to need 2 probes with the hoses. All right, so our next step is going to be drilling some access ports for our probes. The first one's going to be after the filter and before the blower motor. And you want to make sure that you have space for your probe. It's not going to hit anything. And you also want to make sure you're not going to hit the blower wheel housing. The second one's going to go between the evaporator coil and the heat exchanger. And you want it about 2 inches away from the seam. And the reason you want to go underneath is because you have the risk of hitting the drain pan or the coil. You could cause a leak either way. Now, if you don't feel comfortable with that, we have another option for you. You would go to the heat exchanger on your high limit side, and you would take off your high limit switch, and you can put your port, your probe in there. So next step is going to our app, and we want to make sure that we zero it out. Now, I use Measure Quick. This is the one that I recommend. So once you've zeroed it out, we're going to go ahead and insert it. And you'll see an arrow here, and you want to go against the airflow. Same thing with this one. And on these, you can face up or down. If you have a small hole here, you only want to face it with the flow of airflow. But if you don't, and they're on the sides, then it doesn't matter which way you face it. Next thing is we're going to go to a thermostat and make sure that it's dropped down pretty low. And the reason we're doing this is that if the system goes at 100%, or in this case, second stage, in communicating, you're going to put it on test mode, and that way it runs at 100%. And that'll give us the proper static pressure. So right now we're at 0.41 and 0.23, so that gives us 0.64. And right here on your data tag, even on air handlers, it'll tell you what it's set for. And if you're working on a system that's a 2-ton, you want to make sure that your CFMs are going with that 2-ton, right? Same thing with any unit that's not going to tell you what the CFMs. Look at the manual and make sure that you're comparing the blower speeds to the static pressure. That way it'll give you your CFMs, and that's the way you'll get your proper readings. So I have 2 questions for you, Max.
Yes, sir.
How important is static pressure to the unit, and why?
Static pressure is extremely important to a unit. Not only does it verify that you have proper return and proper supply, but it makes sure that we're pulling enough airflow across the coil to get a good temperature split, and make sure the unit's not over-condensating and pulling out the correct amount of moisture from the house. So that will have effects with humidity inside a home, as well as the comfort level for our customers.
Excellent. Thank you, Max.
You're welcome. Hey, did you check that drain line?